Here we are asked to solve the linear quadratic systems by graphing. And so to do this, the first thing I always want to do is make sure that it's y equals a bunch of stuff, because that's how we graph. We set this equal to y, so it becomes negative x plus 3, and the second one is good to go. So I'm going to graph the linear part first. For this one here, I see that I have a y-intercept of 3 and a slope of -1. And so hopefully I can have like a decent arrow here. Oops. And next we're going to graph the quadratic, which takes a little bit more to do because this is in standard form. So I need to find the x value of the vertex by using the axis of symmetry, which is -b over 2a. So I have -4 over 2 times 1, which is just 4 over 2, which is just 2. And then I'm going to use this equation here and plug in 2 to get my y value of my vertex. So it would be y equals 2 squared minus 4 times 2 plus 5, 4 minus 8 plus 5. And I end up getting 1. So my vertex is at 2, 1. 2, 1. Which I see that also is one of my solutions to my answer here, but I'm going to graph the rest of this parabola just to make sure if there's any other ones. So I'm going to plug in 3. So I got 2, 1. I'm going to plug in 3 and 4, and then I'm going to go ahead and mirror that over to the other side because I know it's symmetrical around the vertex. So 3 squared minus 4 times 3 plus 5, 9 minus 12 plus 5, -3 plus 5, and I get 2. Then if I plug in 4, you get 4 squared minus 4 times 4 plus 5, 16 minus 16 plus 5, which is just 5. So 3, 2, 4, and 5. And then I'm going to mirror that. So 1 and 0 are going to have a 2 and a 5. So 1, 2, there's my other solution, and 0, 5. So my parabola here in orange, I see crosses 2 times. So 2 solutions. The first one is 1, 2, and the second one is 2, 1. And if I wasn't sure if those were my solutions or not, I could plug them back into either equation, and it should make both of them true. I always like to write my answer as coordinates. Second one, same idea here. We're going to do pretty much the same thing. I want to make sure that it's y equals, so I'm going to subtract x from both sides. Graph that with a y-intercept of 5, a slope of -1. And then for the second one, I got to use, since it's in standard form, -b over 2a, -10 over 2 times -1, -10 over 2. So my x-axis of my vertex is 5. And then I'm going to plug that into this equation to get what the y value is. So -5 squared plus 10 times 5 minus 19. -25 plus 50 minus 19. And I end up getting 6. So 5, 6, 1, 2, 3, 4, 5, 6. And I need to now plug in some x and y values to get my parabola here. So 5, 6 is my vertex. So I'm going to plug in 6 and 7 to see what I get. And then I'll reflect that over. And hopefully that'll be enough points. But if it's not, we'll just keep plugging more points in. So -6 squared plus 10 times 6 minus 19. So this becomes -36 plus 60, which becomes 14. Nope, I lied. 24 minus 19, which is 5. And now I'll plug in 7. Negative 49 plus 70 minus 19. So that becomes 21. Nope, 30. Nope, 21 is good. And minus 19. That becomes 2. So I'll plot those points. I also have these that mirror. So 3, 2. Oop, I got a solution there. 4 and 5. 6 and 5. 7 and 2. And it looks like if I were to continue drawing this, that it's going to connect farther down. So I'm going to extend both my red line here and see where my blue line keeps going. So I'm going to plug in 8 next and see what I get. So I got negative 64 plus 80 minus 19. So this becomes now, what's that, 14? Nope, 16. And that's negative 3. So 8, 1, 2. Okay, there's my second solution right there. And so my two solutions I see cross at, was at 3, 2, and 8, negative 3. And that's how we both graph linear functions, quadratic functions, and then solve this system of equations.